Lasers are a big part of modern day science. So not only is it kind of like mainstream and very high, high impact science that lasers are involved in, but it's also in industry all over the place.
When the public thinks about lasers, perhaps they think about military applications and weapons. In the 1980s, Star Wars was a big topic.
I think people don't typically fully grasp what we do here at SLAC. We're not like stormtroopers firing away and running around. My name is Mike Minitti, and I am a staff scientist within the Laser and Science Technology Division of LCLS.
I'm Mike Woods. I'm the Laser Safety Officer at SLAC. Lasers are used in a lot of embedded products. So laser printers.
Making semiconductors. Reading within your hard drive of your computer is an optical device. SLAC has tons of lasers here.
We have 25 different facilities operating with high-power lasers.
It's one of the world's preeminent world-class laser facilities supporting all types of science, from chemistry to biology to physics to atomic physics. It's pretty intense. Laser light, as we see it, is a result of a change in energy from one form to another. It's a really bright light source, if you will, that is directional, highly pointed, straight, coherent in nature, and it's made of, photons.
At SLAC, for our research and accelerated physics, we use high-power lasers that require a lot of controls, a lot of training for the personnel. Laser labs can include a lot of different systems. Sometimes you're developing techniques for how to develop lasers. Some of the work here is in developing lasers and capabilities and parameters that would then have use elsewhere.
Here at SLAC, we're one of a few facilities within the United States Department of Energy that is mainly a user facility. So people from all over the world can write a scientific proposal to come use this facility for free. In many of the experiments here at SLAC and namely at LCLS, we have to deliver an optical good to the user to help their experiment perform right. The users will request varying types of parameters that we have to deliver. And with our lasers that you kind of see in the background, they're very powerful and usually generate around a one color of light, around 800 nanometers. But sometimes they want something a little different than that. So we use different types of materials and optics and types of optomechanic pieces in order to shape, control, diagnose, change the wavelength up or down in terms of longer or shorter wavelength.
Laser safety is important. We don't want to injure other people. We don't want to injure our own eyes.
Here at SLAC, there's a large push to always work safe, and working with lasers is no different.
We have well over 200 qualified laser operators at these facilities. And so given that large number of laser operations and personnel, we need safe practices by each and every one of those operators.
We have a great team of laser physicists here. It's not necessarily Star Wars or Star Trek, but it's actually quite fun.